Have you ever wondered how scientists are able to detect the presence of the virus that causes COVID-19, Sars Cov-2? The answer may be more fascinating than you think, and it involves a technique known as surface-enhanced Raman Spectroscopy. Surface-enhanced Raman Spectroscopy, or SERS, is a powerful tool in the field of analytical chemistry. It's a technique that enhances the intensity of Raman scattering, which is a process that occurs when light interacts with a molecule and results in a shift in the energy of the light particles or photons. This shift in energy provides valuable information about the molecule, including its structure and composition. The enhancement in SERS comes from the interaction of the molecule with a roughened or nanostructured metallic surface, typically silver or gold. When the molecule is in close proximity to this metallic surface, the Raman scattering signal is greatly amplified, making even trace amounts of a substance detectable. So, how does this relate to SARS-CoV-2 detection? Well, the virus has unique structural proteins, specifically the spike, S, and nucleocapsid, N proteins. These proteins are distinct to SARS-CoV-2, and their presence can confirm the existence of the virus. In SERS, scientists use nanoparticles coated with a layer that selectively binds to these S and N proteins. When the sample, possibly containing the virus, is introduced, any SARS-CoV-2 present will bind to these nanoparticles. The sample is then exposed to light, and the interaction between the light and the bound proteins results in Raman scattering. The enhanced Raman scattering signal is collected and analyzed to provide information about the presence and quantity of SARS-CoV-2. To summarize, surface-enhanced Raman spectroscopy is a technique that amplifies the Raman scattering signal of a molecule when it's near a metallic surface. In the context of SARS-CoV-2 detection, SERS uses nanoparticles that bind specifically to the virus's S and N proteins. The presence and quantity of the virus are then determined from the Raman scattering signal. This technique offers a highly sensitive and specific method for detecting SARS-CoV-2, making it an invaluable tool in our ongoing battle against this global pandemic. It's a perfect example of how the intricate world of molecular interactions can have huge implications for our everyday lives. From understanding the structure of a tiny virus to diagnosing a worldwide health crisis, the power of surface-enhanced Raman spectroscopy is truly remarkable.